3, we're going to look at combinations. In combinations, we don't arrange the selections in order. So here, order doesn't matter. So here's our example, Tom and Jerry, or Jerry and Tom. The order doesn't matter, so it's only one combination here. They're the same cat and mouse. Only one combination. Order doesn't matter. It represents choices. So C for combination, C for choices. Some keywords when you see a combination problem are selection, and choice. How many options would you choose? So we have a C in the middle, still an N and an R. This notation is different. Think about maybe this parentheses as a very large C. So if you saw a question, like we see in example 2, we have these parentheses around 5 and 2. That's a combination. So I just don't want you to get confused and think that's a permutation. Big parentheses needed to see. So the only difference with this formula is that we're taking the permutation formula and then we're dividing it by r, so or r factorial. So we have an r factorial in the denominator now. We did not have that earlier. So if we take 8 choose C, so our n is 8 this time and our r is 3. We're going to have 8 factorial over 3 factorial times 8 minus 3 factorial. 8 factorial over 3 factorial times 5 factorial. So on the top, if we have 5 factorial, I know that I'm just going to be left with an 8, a 7, and a 6 on the top because the rest of it will cancel out with the denominator. And I'll write it all out again. We have 3 factorial times 5 factorial. And these 5 factorials will cancel on both top and bottom. Well, 5 times 4 times 3 times 2 times 1. And then we also see this 3 times 2 times 1. Well, that equals 6, so I can cancel that out with this 6 up here. And I'm just left with 8 times 7, which is 56. So it's a much smaller number than permutation since order doesn't matter. So in example 1, if we have 8 options and we're choosing 3, we would get 56 possible choices. In example 2, we're taking 5 and we're choosing 2. So you can try this in your calculator. You can go to math, scroll over to probability. I think this is option 3. So you can try it there or try it with me here. So we have 5 times 4 on the top because I know 3 and lower will cancel out with the 3 factorial over this 2 factorial. So I have 20 over 2, which equals 10. And I know I'm squeezing that in there. Just another example of a combination. Using a standard deck of cards, which has 52 cards, if order is not important, so when they tell us that order is not important, we know we're using a combination. How many different 7-card hands are possible? So out of 52 cards, we're choosing a 7-card hand. So when we put that in our calculator, since it will be very large to count down from 52, use your calculator, math, scroll over to probability, option 3. Make sure on your home screen you're typing in your 52 first. Then go to math, scroll over to probability, option 3. Then type in the 7 and hit enter. You should get 133,784,560. And that is a lot of choices. Then we have part B. How many of these hands have all 7 cards of the same suit? So we have, if you're not familiar with cards, we have spades, hearts, diamonds, and clubs. So there are 4 suits in a deck of cards. So how many cards per suit? We have 52 cards and 4 suits. That means we have 13 cards in each suit. So here we're taking, out of the 13 diamonds, let's say, we're choosing 7. So we want to see how many hands have only diamonds. How many 7 cards hands only have diamonds. We're going to add that to the number of heart hands we can have. And then we have 3 more. We have spades and clovers. Clubs, that's what you call them. So if we have 13, choose 7, we get 17, 16, 1,716. And we have 4 of those. So I can add it to 3 others, or I can multiply it by 4, either way. Our total, though, is 6,864. So I got that by taking 1,716 and multiplying it by 4. Or you can simply add 1,716 to 1,716 to 1,716. I'm going to do it for each suit. We have one more type of problem we're going to look at today. It says, find the number of distinguishable permutations of the letters in the word. To do this, we're going to start with, total number of letters. We're going to count the number of letters up. Take the factorial of that number over the number of repeated letters. And then factorial of that. So in this first problem we have 1, 2, 3, 4, 5, 6 letters. So 6 factorial over the number of repeaters. Well, we don't have any repeaters. There are no letters that I see there twice. So 6 factorial is 720. In the next problem, baby has 4 letters, but we have 2 repeaters. This position repeats, and also this letter will repeat. So even though it's the one letter B, we still say that there are 2 repeaters, because there's 2 places where we see that letter B. So we're going to have 4 times 3, which is just 12. And in Virginia, there are 8 letters. And I see 3 I's. So we're going to have 8 times 7 times 6 times 5 times 4. Or you can just do this in the calculator. You'll find your exclamation point under the math if you scroll over to probability again. So if you could please write a summary sentence about what you learned and try the problems on the back. We'll go over them when you get to class. Thanks.